If I block somebody's screen, I block somebody, then you can move your seat. So what happened is a lot of people don't know the whole big picture. So what I'm going to do is I'm going to go through them all, and then we're going to show you what a small aspect of a factoring. So now, did they shut off?
No.
No? What happened? You had a question? So factoring. So if I start with factoring, it's going to be factoring. So what kind of things that you can think about factoring? Like what do you know? What kind of factoring you know? And what kind of things that you pay attention to? So factoring.
In terms of squares?
Perfect square, good. Let's start with perfect squares. Are they 2 terms or 3 terms? 2 terms. They are 3 terms too. It's called perfect square trinomial. Perfect square trinomial is 3 terms. Difference of the square is 2 terms. So they are perfect squares, right? What else? Yes. Quadratic formula, you don't use quadratic formula to factor. However, you can, but it's much more tedious to do that. Okay, so what else about factoring that you guys think of? Yes?
Greatest common factor.
Greatest common factor, good. Okay, so greatest common factor, that's what we're gonna start with. Greatest common factor. So the first steps, always look at greatest common factor. So the first step, you must go through this channel. This channel is gonna say, I'm gonna take care of GCF, okay? GCF factoring. Before anything, always look at GCF factoring, okay? What I mean GCF factoring is also, I always suggest this, factor out the leading coefficient that's negative. So leading negative sign. Okay, the leading one. If the first term starts with negative, if you have descending order, I will factor out a negative sign if I factor out anything. So I'm going to give you a couple examples of that. So here are the examples. We're going to write in red and blue. Black. Okay, so we're going to talk about examples. Sorry, I meant to do the right trash can. That was a mess up. I was trying to throw some art in there. Now I was live streaming that, so that was. Okay, so anyway, so we're gonna talk about examples. So. What is it?
I said you lose 300 followers, can't live stream.
Oh, no, don't do that. Okay, so let's start with a simple example. So let's say example 6x squared minus 6x. Actually, let's go with 12. Okay, let's factor in those. Second question is I can factor out negative 6x to the third plus 12x squared. The third question, so that's mixing x and y's. So negative 2x squared y minus 4xy. So those are examples, yes?
For the first one, is that a 12?
12, yes. Let me rewrite that. And the fourth, that's gonna say, let's factor out, let's say, like you say 3 terms, so it's gonna be negative 6x to the third, y to the first, minus 12xy plus, let's say 9xy squared. Okay, Let's factor all that out. So we're gonna look at all the simple GCFs before we do anything. So remember, first step is always what Daniel says, GCF. Okay, so regardless of anything, any other type of question, always gonna look GCF first. If you forget GCF, the rest of the things that we're gonna do on the bottom, it might be wrong. Now, is all the time they have GCF? No. Sometimes they have GCF. In this case, they all have GCF, and that's the only thing you can factor out. So let's start with first term. 12x squared minus 6x. What do they have in common between two terms? So they both have 6, because 12 divided by 2 is 6, and 6 divided by 6 is 6. So I can factor out as 6. So factor out 6x, right? And we're gonna write a parenthesis here. Okay, so what can I factor out? What after I factor out, what do I have? If I have chopstick, I would catch with chopstick. See the Asian Kung Fu movie? So what happens if I factor out 6x? So do that with what? Well, 6x times 1 equal to 12x squared? 2x, good. 6x times what equal to 6x? Minus 1. So that's it. A simple factoring like this, it goes a long way. On SAT, on ACT, on any other type of test, that simple factoring goes a long way. So not everything is about trinomial, not everything is about binomial, not everything about polynomial. It's just simple factoring GCF. Good old GCF. Look at what two terms are like. Now second one, you're gonna do it, but except you have to pay attention to factor out the leading negative sign. It's really helpful to factor out leading negative sign because when we talk about projectile function, when you're throwing something up and how long it takes to come down, and that first term is always negative 16. So it's always important to factor out the leading coefficient that's negative. Let's look at two terms. What do they have in common? So let's look at a number. What can I factor out between 6 and 12 again? 6. What else? X squared. Not x to the first because they both have x squared in them. So then I will factor out 6x squared, and then I will also factor out one more thing. What do I factor out? Negative sign. Make sure you do that because that's going to get a habit of solving different type of problem. That's going to help you in the long run. So then you multiply this by the first term, so there's two terms here, there's two spaces here, and then you say, okay, negative 6x squared times what equal to 6x to the cube? X to the first. That's it. Now, how do I get a second term? Negative 6x squared times what number equal to 12x squared? Well, first sign change, right? So there must be a negative, and then 2. And that's it, you're done. Simple things like this, it goes a long way for solving the problem. A lot of people think that's too easy, but a lot of people don't look at this first. Even my calculus students are doing this wrong, which is kind of surprising. Now what do we have here? Now I can factor out here. Now do you guys see x and y's now? Yes?
Negative 3x1.
What'd you get 3?
Wait, that's the third one or the fourth one?
Third one.
Negative 2x1.
Negative 2xy. Are you senior? Okay, so what happens if we factor out? I have something left. Negative 2xy times what number equal to negative 2x squared y? So the only thing I'm missing is the x, right? So just x. Going too fast? Okay, now what's the last term? Plus 2. Good. You guys all did a wonderful job. Factor by grouping. I mean, not factor by grouping, factor by GCF. Same thing on the last one. So let me call somebody. Let's say you. What's your name?
Me?
Yeah.
Oh.
What can I factor out here?
3.
3, good. What else? Is the first term negative? So can I factor out a negative? You should, right? So factor out a leading negative sign, right? So I'll factor out. Somebody else can help me the rest of the things? Let's go with you.
X,
X,
Y.
Y, Y. They both have X, Y. They all have X, Y, right? But not X squared Y because this one doesn't have X squared. So they all have X, X, X. So X cubed, X, X. So they all have X, not X to the cube. And they all have Y, but not Y to the second, so it's a Y here. So once you factor out, that's gonna be multiply this by what equal to this?
2x squared.
2x squared
Plus 4.
plus 4
Minus 3y.
minus 3y. Perfect. So all you guys did a wonderful job. That's a factor by grouping, not a factor by GCF. It turns out factor by grouping are very similar. Okay, factor by grouping are very similar. So we're gonna talk about, let's start with 2 term, 3 terms, and 4 terms. But let's talk about 4 terms first. Okay, 4 terms has something called factor by grouping. So we have possible things. Here is 2 terms. Let's talk about the whole big picture. 2 terms have a squared minus b squared. That's equal to a plus b times a minus b. Now on SAT, this is like a powerhouse. You don't see a question, SAT question doesn't have a difference of a square. There's no way that you're gonna avoid this. So this one is something that you need to know for sure. Okay? Now there are sum and difference of the cube. We can talk about that too. So sum and difference of the cube. Now most of you guys don't know this. Of cube. So first of all, that's what Daniel remember was a to the cube plus b to the cube is equal to another thing to remember. Acronym is a SOAP. Acronym. SOAP. What do I mean by SOAP? SOAP. That S stands for Sam. Same sign. Okay? This stands for always the opposite sign. And this stands for always positive. So since you're in pre-calc, you need to understand this. So a cubed plus b cubed is equal to, the first one's going to be the same, so it's going to be a plus b. See the same sign, plus, that's going to apply to here. The next one is going to be what? Opposite sign, so you start with the positive, it's going to be negative sign. And the last part is going to be plus, okay? So there are 3 terms here. One is going to be a squared, ab, and b squared. So that is the first term about things. So let me rewrite this. This is the same sign. And this is opposite sign. Okay, now there's a difference also. It's a cubed minus b cubed is equal to a minus b. Does that make sense? Same like this without a cube. And then it's going to be a squared, ab, b squared. The sign is going to be like this. You start with negative. The second one's going to be what? positive. And the last one is always positive. So this new formula is like this. Now on pre-cal, there's one more thing that you might not know, but we're going to talk about this. This one is not really needed for Algebra 2. Those two are not needed for Algebra 2. This is needed for a pre-cal, which is this part. Here is, what if I have a squared plus b squared? Are they factorable? Okay. It turns out they are. But in Algebra 2, we lie to you. We say, well, we cannot factor this. This is called a prime. It's not factorable. But it's actually factorable. So this one is factor using same idea of difference of the square, but using also another idea with the I. So it's going to be a plus bi times a minus bi. If you know I squared, it's going to turn to what? Negative 1. And negative 1 times negative becomes positive. So if you work it out, you actually end up to be this. But we're going to talk about this in pre-cal a little bit more. But in Algebra 2, we omit this. We told the student that's not factorable, which is a lie. Because we tend to lie student when we're Algebra 2 student because they don't need to know a little bit more. So you need to know one more thing that's more extensive in Algebra 2. Question about this part. Am I on the picture? I'm not on the picture, but is everything on the picture?
Yeah, you're good.
Okay. So that's 2 terms. Okay? And let's talk about 4 terms, which is 4 terms. Which color I use? Use this one. So 4 terms. It's a factor by grouping. How many of you guys hear factor by grouping before? Okay, good. Factor by grouping, or the things about it is you're gonna have 4 terms, and they're gonna be factor by grouping. So I'm gonna give you an example. So 4 terms, usually they are factor by grouping, but they are example, not exception. Factor by grouping. But there are 4 or more terms, 4 terms or more. Okay, 4 terms or more, and they're gonna require use something else. 4 terms or more, sometimes you might use something called factor theorem, synthetic division, and long division might be. Long division. And remainder theorem. This we're going to talk about the whole chapter, so we're going to talk about it later. So we're going to look at this whole picture first, and we're going to talk about this later. This is all the way to the end, where you have to use all different kind of math to deal with this. So we talk about this later. So you should have color code. This is blue, because that's what should be blue. Because we're not going to use until later. So what do I mean by factor by grouping? They have a question like this, factor by grouping. So we're going to talk about this questions here. It's 5p squared plus 5 plus pq squared plus p plus q, sorry. So this are more closest to this. Okay, so 4 terms, factor by grouping. This one is the closest thing from here. All we gotta do is do one step. That one step is really, really important, is put a parenthesis on here. And for me, I will put a parenthesis right here. Let's put a parenthesis there. Out of this parenthesis, I can factor out something. What can I factor out on the first 2 terms? 5. So I'm going to factor out a 5 parenthesis of what? P squared
Plus 1.
plus 5, right?
Plus 1.
Plus 1, sorry, thank you. So P squared plus 1. And I can factor out more. What can I factor out here?
Q.
Q. And then I'm going to get what? Oh, did I write my question wrong? Hold on a second. P. Oh, this one is square P. Sorry. P squared Q. So I can factor out Q. That's equal to P squared plus 1. Does that make sense? Now what I'm going to do is I'm going to factor out a P squared plus 1. And then it's going to be 5 plus Q. I can factor this out, outside, and then I'm going to get P squared plus 1, and this is the 5 plus Q. Oh yeah, test, make sure you give it back, pass forward the test.
I'm just doing it now.
Okay.